When extending electrical service between two townhouses that share a common meter setup, several options exist, each with its own advantages and disadvantages. One option is to run conduit under the slab. This method involves encasing the service cables within a protective conduit buried beneath the concrete slab that typically forms the foundation of the townhouses. Another option is to install an overhead service drop. This entails running cables aerially from a utility pole or other suitable structure to the second townhouse. Let's examine each option in detail. Firstly, consider the conduit under the slab method. The advantages of this approach are threefold. 1. It provides a permanent and concealed installation. By burying the conduit and cables, the installation is aesthetically pleasing and protected from the elements and accidental damage. 2. It protects the cables from damage. The conduit acts as a physical barrier, shielding the cables from impacts, moisture, and other environmental factors. 3. It allows for future additions or modifications. The conduit provides a pathway for adding or replacing cables as needed without requiring major excavation. However, there are also drawbacks to consider. 1. It requires cutting through the slab, which can be expensive and disruptive. Sawing through concrete is labor-intensive and can create dust and noise. 2. It may not be feasible if the slab is thick or reinforced. Thick or heavily reinforced slabs can be difficult and costly to cut through. Secondly, let's examine the overhead service drop method. The advantages of this approach are twofold. 1. It is less expensive and disruptive than conduit under the slab. Overhead installations typically involve lower material and labor costs compared to underground work. 2. It can be installed quickly and easily. Overhead installations are generally faster and less complex than underground installations. However, there are also disadvantages to consider. 1. The cables are exposed to the elements and potential damage. Overhead cables are susceptible to weathering, wind damage, and accidental contact. 2. It may not meet local building codes or aesthetics. Some jurisdictions may restrict overhead service drops due to safety concerns or visual impact. Now let's talk about the recommended option. If the distance between the two townhouses is not excessive and the slab conditions are suitable, conduit under the slab is often the recommended option. This approach offers a balance of permanence, protection, and future expandability. If you choose the conduit under the slab option, follow these steps. Step 1. Install a 200 amp disconnect in the basement of the first townhouse. This disconnect will serve as the main point of control for the electrical service to the second townhouse. Step 2. Cut a trench in the slab between the two townhouses. The trench should be deep and wide enough to accommodate the conduit and cables. Step 3. Install conduit in the trench and run 2 sets of service cables through it. The conduit should be made of durable materials such as rigid metal conduit or Schedule 40 polyvinyl chloride. The service cable should be sized appropriately for the load requirements of the second townhouse. Step 4. Connect one set of cables to the disconnect in the first townhouse. Ensure that all connections are made properly and securely. Step 5. Run the other set of cables to the panel in the basement of the second townhouse. Again, ensure that all connections are made properly and securely. Step 6. Backfill the trench and restore the slab. Use suitable backfill material and compact it properly. Prepare the concrete slab to match the surrounding surface. If conduit under the slab is not feasible, consider these alternative options. One alternative option is to install conduit on the exterior. This involves running conduit along the exterior wall of the second townhouse and running the service cables through it. Ensure the conduit is securely fastened and weatherproof. Another alternative option is an overhead service drop and metering. This involves installing a service drop from the utility pole to the second townhouse and placing a meter base on the exterior wall. This option requires coordination with a local utility company. When selecting an option, several factors should be taken into account. Consider the distance between the townhouses. Longer distances may make conduit under the slab impractical or require larger cable sizes for overhead service drops. Evaluate the slab conditions. Thick or heavily reinforced slabs can make conduit under the slab prohibitively expensive. Assess local building codes and regulations. Ensure that the chosen option complies with all applicable codes and regulations. Consider aesthetics. Choose an option that is visually appealing and minimizes the impact on the surrounding environment. Furthermore, safety is paramount when working with electrical systems. Always disconnect power before working on any electrical components. Wear appropriate personal protective equipment, including safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician. Here are some important considerations for choosing the right conduit for your electrical project. The type of conduit you select depends on the specific application and environment. Different types of conduit offer varying levels of protection against physical damage, moisture, and corrosion. Metallic conduits, such as rigid metal conduit, intermediate metal conduit, and electrical metallic tubing, also known as EMT, provide excellent mechanical protection and can be used in exposed or concealed locations. Non-metallic conduits, such as polyvinyl chloride and high-density polyethylene are lightweight, corrosion-resistant, and suitable for underground or damp locations. Flexible metal conduits, such as liquid-tight flexible metal conduit, liquid-tight flexible metal conduit, and flexible metallic tubing. Flexible metallic tubing allow for movement and vibration and are often used in tight spaces or where equipment needs to be repositioned. When selecting conduit, consider the following factors. 1. The environment where the conduit will be installed. For example, areas with exposure to moisture or corrosive substances require corrosion-resistant conduit. 2. The type and size of conductors that will be installed within the conduit. The conduit must be large enough to accommodate the conductors without overcrowding. 3. The mechanical protection required. Areas subject to physical damage require conduit with higher impact resistance. 4. Local electrical codes and regulations. Ensure that the selected conduit complies with all applicable codes and regulations. Proper installation techniques are essential for ensuring the safety and longevity of the electrical system. Always follow the manufacturer's instructions and use appropriate fittings and connectors. Support the conduit properly to prevent sagging or damage. Seal conduit ends to prevent moisture from entering. Ground the conduit according to code requirements. Here are some additional best practices for electrical installations. Always obtain necessary permits before starting any electrical work. Plan the layout of the electrical system carefully, considering future needs. Use high-quality materials and components. Follow all applicable electrical codes and regulations. Test the electrical system thoroughly after installation. Keep accurate records of the electrical system for future reference. Finally, let's explore some common mistakes to avoid in electrical installations. Overloading circuits. Ensure that the load on each circuit does not exceed the ampacity of the wires and the rating of the circuit breaker. Using undersized wires. Select wires that are appropriate for the load and the length of the run. Making loose connections. Ensure that all connections are tight and secure. Neglecting to ground the electrical system. Grounding is essential for safety and prevents electrical shock hazards. Ignoring electrical codes and regulations. Always comply with all applicable codes and regulations. Here are some key considerations for wire selection in electrical installations. Selecting the right type and size of wire is critical for ensuring the safety and reliability of an electrical system. Wires must be able to carry the intended load without overheating, and they must be protected from physical damage and environmental factors. Different types of wires are designed for specific applications and environments, and it is essential to choose the appropriate wire for the job. Here are some common types of wires used in electrical installations. Thermoplastic high heat resistant nylon coated THHN is a general-purpose building wire commonly used in residential and commercial wiring. It is suitable for dry and damp locations and has a temperature rating of 90 degrees Celsius, which is 194 degrees Fahrenheit. Thermoplastic high water resistant nylon coated THWN is similar to THHN but is also suitable for wet locations. It has a temperature rating of 75 degrees Celsius, which is 167 degrees Fahrenheit in wet locations, and 90 degrees Celsius, which is 194 degrees Fahrenheit in dry locations. Thermoplastic underground feeder (OFF) is a type of cable designed for direct burial in the ground. It is commonly used for underground wiring of outbuildings, landscape lighting, and other outdoor applications. Mineral insulated metal sheet (MI) cable is a type of cable that consists of copper conductors insulated with a mineral compound and enclosed in a copper or stainless steel sheath. It is highly resistant to heat, fire, and corrosion and is often used in high temperature or hazardous environments. When selecting wires, consider the following factors. The ampacity of the wire. The wire must be able to carry the intended load without exceeding its ampacity rating. The voltage drop. The voltage drop in the wire should not exceed 3% of the source voltage. The environmental conditions. The wire must be suitable for the environment in which it will be installed, such as wet, dry, or corrosive environments. The type of insulation. The insulation must be appropriate for the voltage and temperature of the application. Local electrical codes and regulations. Ensure that the selected wire complies with all applicable codes and regulations. Here are some tips for working with wires. Always disconnect power before working on any electrical wiring. Wear appropriate personal protective equipment, including safety glasses and gloves. Use wire strippers to remove insulation from wires without damaging the conductors. Make sure that all connections are tight and secure. Avoid over-tightening connections, which can damage the wires. Label all wires clearly to avoid confusion. Use cable ties to bundle wires together neatly. Here are some common wiring mistakes to avoid. Using undersized wires. Select wires that are appropriate for the load and the length of the run. Overloading circuits. Ensure that the load on each circuit does not exceed the ampacity of the wires and the rating of the circuit breaker. Making loose connections. Ensure that all connections are tight and secure. Mixing different types of wires. Use only compatible types of wires in the same circuit. Neglecting to ground the electrical system. Grounding is essential for safety and prevents electrical shock hazards. Ignoring electrical codes and regulations. Always comply with all applicable codes and regulations. When extending electrical service, remember that the National Electrical Code (NEC) provides comprehensive guidelines for electrical installations, including service entrances, wiring methods, grounding, and overcurrent protection. Familiarize yourself with the applicable requirements of the NEC to ensure a safe and compliant installation. Here's an overview of key NEC articles relevant to extending electrical service. Article 225 Outside branch circuits and feeders covers requirements for electrical wiring installed outside buildings. Article 230 Services addresses the installation of service conductors, service equipment, and overcurrent protection. Article 250 Grounding and bonding provides requirements for grounding electrical systems to protect against electrical shock hazards. Article 300 Wiring methods outlines general requirements for wiring methods, including conduit, cable, and raceways. Article 310 Conductors for general wiring specifies requirements for conductor ampacity insulation and identification. When extending electrical service between townhouses, pay close attention to the following NEC requirements. Service entrance conductors must be sized according to the load requirements of the building they serve. Overcurrent protection must be provided for service entrance conductors and branch circuits. Grounding electrodes must be installed to provide a path for fault current to return to the source. Bonding must be provided to connect all metal enclosures and equipment to the grounding system. Wiring methods must be suitable for the environment in which they are installed. When planning an electrical service extension, it's essential to perform a load calculation to determine the electrical demand of the second townhouse. This calculation will help you select the appropriate size of service entrance conductors, overcurrent protection, and other electrical equipment. The NEC provides guidelines for performing load calculations in Article 220, branch, circuit, feeder, and service calculations. Firstly, calculate the general lighting load. This is based on the square footage of the second townhouse. Secondly, calculate the small appliance and laundry loads. These are based on the number of small appliance and laundry circuits in the second townhouse. Thirdly, calculate the appliance loads. This includes the loads of all fixed appliances, such as refrigerators, ranges, dishwashers, and water heaters. Fourthly, calculate the heating and air conditioning loads. This includes the loads of all heating and air conditioning equipment. Fifthly, calculate any other loads, such as electric vehicle chargers or swimming pool equipment. Once you have calculated the total load, you can use the NEC tables to determine the appropriate size of service entrance conductors and overcurrent protection. Always consult with a qualified electrician to ensure that the load calculation is performed correctly and that the electrical system is designed to meet the needs of the second townhouse safely and reliably. In addition to the NEC, local building codes and regulations may also apply to electrical service extensions. These codes may vary depending on the jurisdiction and may include requirements for permits, inspections, and specific wiring methods. Always check with the local building department to determine the applicable codes and regulations before starting any electrical work. Before starting any electrical work, it's essential to obtain the necessary permits from the local building department. Permits are required to ensure that the electrical work is performed safely and in accordance with applicable codes and regulations. The permit application process typically involves submitting a set of drawings and specifications for the electrical work, as well as paying a permit fee. Once the electrical work is completed, it must be inspected by a qualified electrical inspector. The inspector will verify that the work has been performed in accordance with applicable codes and regulations and that the electrical system is safe to operate. If the inspection is successful, the inspector will issue a certificate of occupancy, which allows the second townhouse to be occupied. Extending electrical service between townhouses can be a complex and challenging project. However, by understanding the options, following the proper procedures, and complying with applicable codes and regulations, you can ensure a safe and reliable electrical installation. Always consult with a qualified electrician if you have any questions or concerns.